In indirect extrusion, also known as backward extrusion, the billet and container move together while the die is stationary. The die is held in place by a stem which has to be longer than the container length. The maximum length of the extrusion is ultimately dictated by the column strength of the stem. This process is especially advantageous for materials with high billet container friction. Here one can see the hollow ram or die forces against the stationary workpiece which has been backed up the flat end and the upper die. The operation is marked by no relative displacement between the containing die and the billet. So we see there is no friction involved between them, which greatly improves the external surface finished on the finished product. However, one has to remove the lower hollow die that has been pierced upwards into the billet regarding extrusion of the part, which sometimes gets stuck to the billet part to certain plastic deformation, also making this process discontinuous. Here in this video one can see on the left hand side of the screen the various components involved in this process. They are the cylindrical container meant for enclosing all other parts, the workpiece being held up against the gravity by the ram action in the cylindrical container, and the lower ram. The right hand side video shows the movement of the solid ram in the upward and downward direction to and fro into the cylindrical bore of the container. The ram looks like piercing workpiece all through its upward movement, but it is not the actual case. Here the workpiece is being deformed by its material flowing outwards from its central axis and downwards as and when they find the suitable space for the flow to take place within the cylindrical cavity provided as shown in the following video.